My name's Julian. I'm the lead data scientist at Gardin. We're a phenotyping technology company based in the UK with operations in France, the Netherlands, the US, and Canada. Now, most of you may be aware of the concept of the climate computer, which enables growers to have target set points and allows the greenhouse to react to changes in weather to maintain a consistent environment for the plants. But how do we know what the right set points are? And what is the effect of those set points on the thing that we actually care about, which is the plant? What if we could have plant set points that ensured consistent, high-quality produce and use the most efficient strategy of getting there? I call this the plant computer, and this is what we're developing at Gardin. So today, growers will talk to you about their climate strategy, things like VPD, DLI, and RTR. And these are used as set points to guide the climate computer. And at the start of the season, growers will come up with a climate strategy using their historical experience and industry best practices to decide what set points they think will be best for their environment. That gets you about 80% of the way there to good outcomes. The final 20% is about fine-tuning that strategy during the season to react to unexpected changes in crop development. And this part is extremely challenging because plants are really hard at telling us whether they're happy or not. The things we care about, like size, quality, and color, are really slow to develop. And the result is that growers typically don't change their strategy very often because they simply don't have the information that they need to make changes and know what the impact of those changes will be on the plant. Gardin was created to solve this problem. We wanted to allow growers to measure the thing they actually care about, the plant, and measure deep plant physiology, specifically photosynthesis. And to do this, we had to design an entirely new sensor from scratch. When we were developing the sensor, we knew there were a few key challenges we needed to overcome. First, I had to be able to measure many plants from a distance of several meters away so that we would be representative of the greenhouse as a whole. Secondly, it had to be autonomous. We didn't want any additional labor required to collect this data. And finally, it needed to be cost-effective so that we could take this amazing technology to the industry as a whole. Now, this was a massive engineering challenge. It was really hard, but we accomplished it early last year, and since then, we've been deploying in commercial greenhouses across the world, finally allowing growers to get feedback from their plants to make decisions. We call this approach plant-driven growing, and we've achieved remarkable results with our partners who've used it. Now let me tell you a story about Leonard and Arjan. Now they run a 4-hectare lettuce facility in the Netherlands, and they grow 7 different varieties of lettuce all under one greenhouse. And that's really challenging because you have to have one climate that makes every lettuce variety happy. Now to Leonard, all the lettuce looks the same. But with Gardin, he now has a continuous measurement of the relative productivity of every lettuce variety at different stages of his production. And he uses that to optimize things like airflow, irrigation, and lighting, and he's achieved remarkable efficiency improvements using it. The plant computer will change the way we grow food indoors. In the past, growers were taught guidelines for how to select their target set points. Take VPD, for example. You'll see generic tables like this that give you recommended generic bands with no relation to your specific environment. With the plant computer, your plants will tell you exactly what they need and how much they can usefully use. Gardin's current product focuses on 2 of the biggest challenges that growers currently face: VPD optimization and lighting control. And I'll take you through some of our results so far. Using Gardin as a feedback loop to improve climate strategy is incredibly effective. We've used it to increase the productivity of our research facility by 40%. We've also worked with a commercial farm to improve their irrigation strategy, increasing annual yields by 8%. Choosing the right LED spectrum is another challenge that the entire industry is grappling with. Using Gardin to measure photosynthesis, we increased the yield by over 30% for three different species in a commercial farm. And finally, at a trial in Delphi, we've been optimizing the lighting strategy of 2 different strawberry varieties to not just grow more berries, but higher quality ones too. So you can see that we're helping growers capture that final 20% and more. I hope to have shown you the enormous potential of using feedback from the plants to make growing decisions. Gardin has been deployed on almost every major greenhouse crop, and we're excited to work with more partners to build the next generation of greenhouse cultivation. Please get in touch to start your journey with the plant computer today. Thank you.